Hi everyone, my name is Gabriel Ferrante, and I will present the work Understanding the State of the Art in Animal Detection and Classification using Computer Vision Technologies. This presentation is divided to 6 parts, starting with the introduction, so after the related works are briefly present. The essential concepts are the present, followed by the state-of-the-art part. At the end, there is a discussion about the results and ending with the conclusions. The implementation of systems that use devices and services to improve urban traffic problems in cities and highways, such as accidents and congestions, increases every day. Among the most applicable services, computer vision systems stand out, which help to understand the dynamic of urban environments. In Brazil, there is still little use of these technological tools, and the solutions used are not very agile and technological. This can be seen when looking at the rate of deaths from accidents on highways, with more than 69,000 deaths in 2019, according to the Institute for Economic and Applied Research. Another category of road accidents very common in Brazil is that involving animals, which represents only 2% of accidents in January. According to the Brazilian Center for Ecology on Roads, more than 475 million animals die on Brazilian roads every year. There is little government investment in the use of these technologies to ensure the safety of animals on the highways, despite strict laws for road companies. Therefore, this work intends to present the state-of-the-art of computer vision techniques for detecting and classifying animals, aimed to position research in the area and encourage further research aimed at the problems similar to the Brazil road scenario. Related works. Below we have a comparative chart highlighting the difference between the works related to this work. Our work has a differential that we approach especially the detection and classification of animals. Essentials concepts. Although computer vision is the main field involved on research of animal detection and classification, the state of the art and the current gaps in the field for the context are not clear, since that there are different approaches and things being applied in rapid evolution. During this study, we identified 6 main use contexts: CNN, DFDL, SVM, HOG, SIFT, and PCA, and among those we can highlight CNN, SVM, and HOG. First, let's quickly understand what computer vision is. Computer vision can simulate human vision through software and hardware sensors used to analyze and process visual information and data. The functioning of a computer vision system has a sequential structure with 3 stages. First, low-level vision include acquisition and pre-processing data. Second, intermediate-level vision, including segmentation, extraction, and normalization of features. And third, high view, include classification, recognition, and matching for data. Convolutional neural network (CNN) is a variation of multi-layer perceptual networks and is often considered the most influential machine learning in the field of computer vision used for object classification, detection, and recognition in images and videos. In addition, CNN outperforms traditional artificial intelligence methods, with SVM, decision tree, and Navy base. As the CNN can learn data characteristics during training, resulting in a significant reduction in the time required for the learning of the model. Discriminative feature-oriented dictionary learning, DFDL. DFDL method learns specific dictionaries of the class that, based on the sparsity constraint, the dictionaries allow to represent a new image through the dictionary corresponding to the sample class. Also, a small difference between classes are maintained, resulting in better sorting performance. The idea is based on solving an optimization problem with dispersion constraints. Support vector machine (SVM). The SVM is a supervised machine learning method based on a non-linear mapping to find a Reaper plan that separates the data class decision threshold. In the way, SVM can be used in the regression and classification challenges being its main for on training and classification of a dataset. Histograms of oriented gradient (HOG). HOG is a feature extractor commonly used in image processing that provides a representation of an image contain relevant details about itself, resulting in a histogram of the orientation of the gradients in the image. The HOG is based on the idea that a shape and aspect of an object can be described by the intensity of gradients and or towards the edges. Scalar invert feature transform (SIFT). SIFT is instructed to extract local features from an image that does not suffer variation in scale, rotation, lighting, and three-dimensional point of view. The identification of points of interest in variation to scale and rotation occurs through Gaussian functions. For this, each point of interest receives a feature vector capable of describing in a unique way the regions of interest, referring to scaling location and coordinate space. Principal component analysis (PCA) is a method that aims to reduce and eliminate data overlaps and assist in choosing or on more representative forms. From the linear combinations of original variables, PCA is a procedure based on a very useful statistical method when the feature vectors have several dimensions, which can make their graphic representation unfeasible and has been used for various purposes, such as facial recognition, image compression, and pattern recognition. Understanding state of the art. The chosen works are published between the period of January 2017 to May 2021. A total of 146 articles were found, and only 20 were selected for this work, as they belonged to area of animal detection and classification. In addition, we looked for research that also involved the application in urban environments. The main criteria for choosing the articles here being defined for of computing or engineering, be full paper or short paper, that present state of the art detection and your animal classification, be written in Portuguese or English language, involving image process techniques or computer vision. After collection, we summarize the articles and separate them into three main categories. The first is about articles that use CNN as it is the majority. The second is about articles that mix more than one techniques. And the third is about less used techniques. In the line chart, you can see a large number of works that use CNN compared to tools that use combinations. The FDL only had one article and the category called Others includes lesser used techniques like histogram equalization and 2D models. It is important to highlight that the category of combined techniques also include tools that use CNN with the others. Discussion. In all, 10 articles use CNN and 7 use combined techniques, and only 3 use less conventional techniques. Despite the constant use of CNN, the use of combined techniques is also banned widely adhered to and even more than the CNN only approaches. The combined techniques identified C, SVM and CNN, SVM and HOG and CNN, PCA and CNN, SWIFT and CNN. Among the study's evaluation methods, 9 studies relies on accuracy, 1 study with precision, 10 studies made use of combination techniques. Combined metrics includes accuracy, accuracy, memory occupied and prediction time, accuracy and precision, accuracy F1 score, memory, CPU utilization, and more. In summary, the main challenges and open questions found are lack of specific architectures for animal detection and classification in urban environments, little use-edge process device for computer vision technologies, no paper test their approaches to check for difficulties in detecting or classifying any specific animal. There was no use of animal datasets specifically in cities. Differences in the use of technology in cities of different size and not reported. Conclusions. It's concluded that the current state of the art of detection and classification animal focus on the use of the neural networks, mainly convolutional on to increase the accuracy of classifications. Some works, in addition to CNN, combining other techniques for specific purposes. A more relevant resulting aspect concerning urban environments is that few works have been used to use techniques for detection and classification of animals in intelligent urban environments. For future works, the search for works that relate to the components of smart cities with animal detection and classification is an interesting topic to be explored. Furthermore, exploring the animal area and its implication for the construction of intelligent transport system is also a line of research to be considered, meant that they utilize computer vision technologies for obstacle detection tasks. Thanks very much and enjoy the event.